Hello! So today we did option 3 of the projects listed on Canvas. So for option 3, we decided to build a truss bridge for teachers to teach the concept of compression, tension, and zero force members for their high school students. And I will be bringing Biih inside the video to present our project to you guys.
Hello, I'm Biih, and this is our truss bridge. We have 3 different colors that will indicate the compression, tension, and zero force members. We have blue to show the tension, we have red to show the compression, and then green for the zero force members.
And during class, we note that there are 2 main methods that we could find forces within the bridge, which is method of sections and method of joints. So for method of sections, a teacher could present this to the class by covering up certain sections of the bridge so that they could have one specific area that they could focus on to teach the high schoolers about how to solve for the forces that they need, whether it be A to B, C to B, or whatever forces.
And then to help with the method of joints, we have this with a circle, and this can be used to target a joint that's a part of the bridge, and then they can find the forces of the different points or the different vectors of the bridge, and that's how that will be used.
We would also like to appreciate Maddie for building this because she took the day of her life, or at least certain hours of her life, to build this. So we would like to appreciate Maddie for doing this for us.
The next thing we made was a PowerPoint presentation, and Maddie will be doing a voiceover explaining how that will be used in a classroom setting.
Thank you.
Hello, it's Madison Hedges here. I'll be going over the wonderful presentation that Anthony and Biih and Abriana made about truss bridges. So to begin, what is a truss? It's basically a structure that's made from different types of material, but it's built in a certain way that certain bars and sections of it can distribute loads in a certain way, whether it's in compression or tension. So compression, it's like or having a force that's going inwards. Tension is like the ends are trying to go outwards in a way. And wire truss is important because they are really effective at holding up for long periods of time. For example, if anyone's been to the Golden Gate Bridge, that would be like an example. So wire truss is important. They're really important because they help us with daily life, such as supporting buildings and providing places for transportation. And so for identifying forces in a truss, we can do different things like Biih and Abriana mentioned. For example, we can expect the joints, and then we can do method of sections and then method of joints if we need to do some more math. So by inspection, we can take a look at a truss bridge, and if we see that there are 3 kind of joints that are in a perpendicular T-shape, and there are no outside forces acting downwards or upwards on, let's say, point B here to the right, on this picture to the right, then we know that that's a zero force because nothing else is going to act on it, and then the X forces are going to be balanced as well. And then this example to the left, we can also tell it's going to be a zero force member from like A to B and A to C, because they are 2 joints that are joined in a place where they have no other forces acting on them. So by method of joints, we can take one singular joint, draw that free body diagram, figure out whether the forces are in tension or compression, use our equations of equilibrium, and then just plug and chug, basically. A teacher could teach method of joints first and teach how to do like one joint at a time, and then maybe from there they can teach the method of sections, where it's like you split a truss down the beams instead of going by the joints. So in this case, we're still going to want to draw a free body diagram, and still use our equilibrium equations, and so that we can kind of like determine how each section of the bridge is going to do with certain forces along it. So specifically for our bridge, the one that we made, it was a Pratt truss. So the teacher might have this model in their class, and they might ask the kids to, try and find the forces in the bridge, identify, maybe by inspection which ones are a zero force. And if they wanted to, then they could also assign values or forces to certain sections of the bridge and try to have the students calculate for compression or tension. But ideally, the bridge that we built would be like a 3D model and a real life example of how these bridges actually work. But yeah, thank you.